The massive classroom on Zarian Prime buzzed with excited chatter as students from across the galaxy settled into their seats. Jake Morrison pulled his datapad closer and tried to ignore the strange looks from his classmates. Being the only human in Professor Zenth's advanced biology course made him stand out like a sore thumb among the dozens of alien species that filled the curved amphitheater. Professor Zenth glided into the room on his 6 tentacles, his bulbous head gleaming under the artificial suns that lit the academy. The mentory professor was known throughout the galaxy for his expertise in comparative biology, and his courses were considered among the most prestigious at the Galactic Academy of Biological Sciences. Jake felt lucky to be here, even if his acceptance had raised eyebrows among the faculty. Today we examine the arthropods of various worlds, Professor Zenth announced, his voice carrying easily through the room's acoustic enhancers. We shall observe how different evolutionary pressures have shaped these creatures across our diverse civilizations. The first holographic display materialized above the professor's desk, showing the crystalline world of Vextar. Elegant glass-like beetles moved across the projection, their transparent bodies refracting light into beautiful rainbow patterns. The Vextari students in the front row straightened with pride as their professor explained how these creatures could manipulate photons and create complex light displays. Magnificent, breathed Crystal, a Vextari student whose own crystalline body sparkled with approval. Our crystal beetles can bend light itself to their will. They communicate through pure photonic energy and can become invisible by redirecting light around their bodies. Next came the aquatic world of Delphia, where massive crustaceans with shells harder than starship hulls dominated the crushing depths of their ocean planet. The Delphian students, their blue-green skin glistening with moisture, clicked their approval as the professor described creatures that could survive pressures that would instantly crush most galactic species. The gaseous beings from Nether floated excitedly as their homeworld's phase-shifting arthropods appeared in the display. These ethereal creatures could shift between solid and gas states at will, allowing them to pass through solid matter like ghosts. The Netherian students, barely visible as shimmering outlines in the classroom's atmosphere, whispered among themselves in their musical gas language. When the display shifted to show Korax and its famous battle wasps, the classroom erupted in murmurs of appreciation. These meter-long creatures possessed stingers that could heat plasma to cutting temperatures, and their chitinous armor could deflect energy weapons. Thelanara, a blue-skinned Koraxian with silver tattoos marking her warrior caste, stood proudly as her species' achievements were displayed. The battle wasps of Korax have been our companions in warfare for millennia, she declared, her voice carrying the authority of someone born to command. They can slice through battle armor and coordinate attacks with military precision that rivals our finest generals. Jake watched quietly as world after world displayed their arthropod champions. Each species seemed more impressive than the last, with abilities that sounded like science fiction even to someone from a spacefaring civilization. He began to feel a growing sense of dread as he realized what was coming next. The holographic display flickered and changed, showing a familiar blue-green world with white clouds swirling around its surface. Earth appeared in all its simple beauty, looking almost primitive compared to the exotic worlds that had come before. And now, Professor Zenth announced with what Jake could swear was barely concealed amusement, we examine the arthropods of Earth, homeworld of our human colleague. The first image that appeared was a common house ant, perhaps 2 centimeters long, carrying a crumb of food. The classroom fell silent for exactly 3 seconds before erupting into laughter. Crystalline. Body chimed like breaking glass. As he laughed, "Is this some kind of joke? That tiny thing could not even survive on our world for a single moment." Zephyr, the Netherian student, condensed briefly into visibility just to point at the display. "It cannot even fly properly. Look at how it crawls along the ground like a damaged machine." The laughter grew louder as more Earth insects appeared. A honeybee visiting a flower prompted giggles from the Delphian students, who compared its clumsy flight to their own graceful swimming motions. A butterfly fluttering through a garden caused the Coraxian students to mock its paper-thin wings. How does such a fragile creature even survive? Thelanara asked, her silver tattoos flickering with amusement. A single breath from our battle wasps would incinerate dozens of these pathetic things. Professor Zenth made no effort to control the classroom's reaction. If anything, he seemed to encourage it by highlighting the insect's small size and apparently simple behaviors. As you can observe, Earth's arthropods appear to lack the sophisticated adaptations we have seen in other species. They possess no plasma weapons, no light manipulation abilities, no phase-shifting capabilities. Jake felt his face burning with embarrassment as his classmates continued their mockery. A student from the crystalline moon of Keth pointed out that Earth's insects had no apparent energy shields. A fungal being from the spore world of Mycelia noted that they seemed to lack any form of collective consciousness. Do they even have proper neural networks? Asked a student whose species Jake didn't recognize. They appear to operate on pure instinct, like biological machines. The worst part was that Jake couldn't immediately argue with them. Compared to plasma-wielding wasps and light-bending beetles, Earth's insects did seem remarkably ordinary. He watched a video of ants forming a simple line to carry food back to their nest, and even to him it looked primitive compared to the complex behaviors displayed by other worlds' creatures. Thelanara leaned back in her seat, her expression one of genuine curiosity mixed with condescension. I mean, no offense to our human friend, but how did your species even achieve spaceflight with such limited biological examples to learn from? Our battle wasps taught us coordination and tactical thinking. What could these tiny crawling things possibly teach anyone? Other students nodded in agreement, and Jake heard whispered conversations wondering how Earth had ever developed advanced technology without sophisticated arthropods to inspire their engineering. The implication was clear: humans must be remarkably resourceful to have achieved interstellar travel despite coming from a world with such unremarkable insects. Professor Zenth called for attention as the display shifted to show assignment details. For your final projects, you will each present a detailed analysis of your homeworld's most remarkable arthropod species. I expect comprehensive research into their unique adaptations, evolutionary advantages, and contributions to their ecosystems. As students began discussing their chosen subjects, Jake heard confident voices planning presentations on battle wasp tactics, crystal beetle optics, and phase shifter biology. Meanwhile, he stared at his datapad, wondering how he could possibly make Earth's insects seem interesting to classmates who controlled creatures that could bend light and cut through metal. Thelanara approached his desk as other students filed out. Jake, I hope you were not offended by our reactions. Perhaps you could focus on some other aspect of Earth biology for your presentation. Your homeworld must have more impressive creatures than those tiny insects. Jake looked at her genuinely concerned expression and managed a weak smile. Actually, I think I'll stick with insects. There might be more to them than meets the eye. She shrugged, clearly thinking he was making a mistake. Your choice, but I cannot imagine what you could say about such simple creatures that would impress anyone in this class. As Thelanara walked away, Jake stared at the images of Earth's insects still glowing softly on his datapad. Maybe his classmates were right and he was about to embarrass himself further. But something deep inside told him there was more to these creatures than anyone in this room realized, including himself. Jake spent the next 3 days buried in the Academy's vast digital archives, searching through every piece of information about Earth's insects that had made its way into the Galactic database. What he found was disappointing and frustrating in equal measure. The records were sparse, often inaccurate, and clearly written by researchers who had spent minimal time actually observing the creatures they described. Most entries focused on basic physical characteristics: size, color, number of legs, basic diet. The behavioral descriptions were laughably simple, describing ants as small creatures that carry food and bees as flying insects that collect nectar. There was no mention of complex social structures, problem-solving abilities, or sophisticated communication systems. Jake rubbed his tired eyes and leaned back in his study pod. The archive's information made Earth's insects sound even more primitive than his classmates already believed. He was beginning to think that maybe Thelanora had been right about choosing a different topic when inspiration struck. He activated his personal communication array and sent a quantum message. Across the galaxy to Earth, the transmission would take several minutes to reach his destination. But it was his best hope for finding the real story about Earth's insects. Lisa Morrison was in her laboratory at the Colorado Research Institute when Jake's message appeared on her communication screen. She smiled when she saw her younger brother's face, though she could tell from his expression that this wasn't just a social call. "Hey, Jake, how's life among the aliens?" she asked when the connection stabilized. "Complicated," Jake replied, explaining his situation and the mockery he'd endured in Professor Zent's class. "Lisa, I need your help. Everything in the Galactic archives about our insects makes them sound completely boring. Please tell me there's more to them than what I'm reading here." Lisa's expression changed from casual interest to excited enthusiasm. "Jake, you have no idea what you're sitting on. The galactic databases are based on research that's decades out of date. We've discovered things about insect behavior and intelligence that would blow your alien classmates' minds." Over the next hour, Lisa began transmitting files that had never made it into the official galactic records. Jake watched in amazement as his sister showed him research that painted a completely different picture of Earth's insects. The first revelation came from studying leafcutter ants. Jake had always thought they simply cut leaves and carried them home, but Lisa's research showed something far more sophisticated. These ants were farmers, she explained, cultivating fungus gardens with techniques that rivaled any agricultural civilization in the galaxy. "They don't eat the leaves, Jake," Lisa said, her excitement evident even across the vast distance. "They use them as compost to grow fungus, and they've been doing sustainable agriculture for 50 million years. They even weed their gardens and use natural pesticides to protect their crops." Jake stared at footage of ants carefully tending their underground fungus farms, selecting the best growing conditions and maintaining perfect climate control. It looked remarkably similar to the agricultural domes he'd seen on advanced worlds throughout the galaxy. The second file dealt with honeybee decision-making, and Jake could hardly believe what he was seeing. When a hive needed to find a new home, scout bees would search for potential locations and return to perform complex dances that communicated not just the location of sites, but their quality ratings. "It's a democratic process," Lisa explained. "The scouts debate through dance, and the entire hive votes on the best option. They consider factors like size, protection from weather, distance from food sources, and dozens of other variables. Their decision-making process is more sophisticated than some government systems." Jake watched bees performing their waggle dances, realizing that he was seeing a form of communication that could convey abstract concepts like quality and suitability. These weren't the simple creatures his classmates had mocked. They were problem-solving communities with their own form of democracy. The third revelation came from butterfly migration research. Jake had always known that monarch butterflies traveled long distances, but Dr. Kevin Phillips's recent work revealed navigation abilities that put most galactic positioning systems to shame. "They use multiple navigation methods simultaneously," Lisa transmitted along with Phillips's research data. "Magnetic field detection, polarized light patterns, solar positioning, and something we're calling genetic memory. A butterfly that's never made the journey before can navigate thousands of miles with accuracy that exceeds our best technology." Jake studied the data showing monarch butterflies correcting their flight paths in real time, adjusting for weather patterns and geographic obstacles with a precision that would impress the Academy's navigation instructors. These delicate creatures were living GPS systems more advanced than anything his classmates' civilizations had developed. As Lisa continued sending files, Jake began to see patterns that the galactic archives had completely missed. Earth's insects weren't remarkable for individual abilities like plasma weapons or light manipulation. They were remarkable for something else entirely: collective intelligence and adaptability. Army ants, Lisa showed him, could build living bridges and form complex structures using their own bodies as building materials. They had no central command structure. Yet thousands of individuals could coordinate flawlessly to overcome obstacles and adapt their formations in real time. Termites constructed air-conditioned cities with ventilation systems that maintained perfect temperature and humidity. Their mounds were architectural marvels that inspired human building designs, with passive cooling systems more efficient than most. Galactic construction techniques, even simple house ants demonstrated problem-solving abilities that challenged assumptions about intelligence. They could learn maze patterns, remember food locations, and communicate complex information about dangers and opportunities to their nestmates. Jake realized that his classmates had been looking for the wrong things. They expected Earth's insects to compete with battle wasps in individual combat or match crystal beetles in specialized abilities. But Earth's insects had evolved something different and potentially more valuable: the ability to work together to solve problems and adapt to any environment. While his classmates studied creatures that excelled in specific conditions, Earth's insects had conquered every habitat on the planet through cooperation and innovation. Ants thrived in deserts, rainforests, and Arctic tundra. Bees had spread to every continent except Antarctica. Butterflies migrated across oceans and mountain ranges that would challenge stars hips. The more Jake learned, the more excited he became. His sister's research revealed that Earth's insects had been developing sophisticated technologies for millions of years before humans even existed. They had perfected agriculture, architecture, navigation, communication, and social organization. While most of the galaxy's advanced species were still single-celled organisms, Lisa's final transmission included contact information for Dr. Kevin Phillips and several other researchers who had been studying insect intelligence and behavior. She also sent footage from recent field studies that had never been published in galactic journals. "Jake," she said as their communication session neared its end, "what you're seeing here represents just the beginning of what we're learning about insect intelligence. These creatures aren't simple or primitive, they're elegant solutions to complex problems. They've had millions of years to perfect systems that we're just beginning to understand." Jake thanked his sister and closed the communication link, his mind racing with possibilities. He looked at his datapad, now filled with research that painted Earth's insects in a completely different light. Instead of primitive crawling creatures, he saw them as master engineers, sophisticated communicators, and problem-solving communities that had achieved things his alien classmates could barely imagine. For the first time since arriving at the academy, Jake felt confident about his presentation. He had something that no other student in the class possessed: creatures that had evolved not for individual superiority, but for collective achievement. While battle wasps were impressive warriors and crystal beetles were beautiful light manipulators, Earth's insects were something else entirely. They were proof that true intelligence didn't require plasma weapons or special abilities. Sometimes the most sophisticated solutions were also the most elegant ones, refined over millions of years of evolution into systems that worked flawlessly in any environment. Jake began planning his presentation, knowing that he was about to challenge everything his classmates thought they knew about intelligence, cooperation, and the nature of biological achievement. The creatures they had mocked might just teach the galaxy a few things about what it really meant to be successful. Presentation day arrived with the usual buzz of excitement that filled Professor Zent's classroom when students were ready to show off their homeworld's greatest biological achievements. Jake sat in his usual spot near the back, watching his classmates make final adjustments to their holographic displays and practice their opening statements. Thelanara went first, and her presentation was everything Jake had expected. The classroom filled with gasps of appreciation as massive Coraxian battle wasps materialized in the holographic display, their meter-long bodies gleaming with chitinous armor that could deflect energy weapons. "Behold the supreme arthropod warriors of Corax," Thelanara announced proudly, her silver tattoos glowing with satisfaction. "These magnificent creatures have fought alongside my people for over 3,000 years. Their plasma-heated stingers capable of cutting through starship hulls." The battle wasps moved through their display with intimidating grace, demonstrating coordinated attack patterns that had been refined through millennia of warfare. Their compound eyes tracked multiple targets simultaneously while their wings beat with mechanical precision. When Thelanora commanded them to demonstrate their plasma stingers, the air itself seemed to sizzle with contained energy. "Impressive," Professor Zenth noted, making entries on his evaluation pad. "The integration of biological warfare capabilities with tactical intelligence represents remarkable evolutionary achievement." Crystal presented next, and the classroom transformed into a wonderland of refracted light as his crystal beetles took center stage. The Vextari student's own crystalline body resonated in harmony with his subjects, creating a symphony of light that danced across every surface. "Our crystal beetles are masters of photonic manipulation," Crystal explained, his voice chiming. "Like wind through glass structures. They can become completely invisible by bending light around their bodies, communicate through pure photonic energy, and create defensive barriers using controlled light interference." Jake watched in genuine amazement as the beetles demonstrated their abilities. They shifted through the visible spectrum like living prisms, communicated in bursts of colored light that formed complex patterns, and even created temporary holographic decoys to confuse predators. It was biological technology that seemed almost magical in its sophistication. The Delphian student Myrthala followed with her deep-sea crustaceans, creatures that thrived in pressures that would crush most galactic species. These massive beings possessed shells harder than starship armor and could navigate the crushing depths of their ocean world with sonar abilities that put military detection systems to shame. Ceph single quotes, "Why are the Netherian barely maintained physical form long enough to present his phase-shifting arthropods, ethereal creatures that could transition between solid and gaseous states at will. They move through solid matter like ghosts, making them nearly impossible to capture or contain." Each presentation followed the same pattern: individual creatures with specialized abilities that exceeded anything found in the galactic archives. Combat prowess, energy manipulation, pressure resistance, matter phasing. Every species had evolved their arthropods to excel in specific, impressive ways. Jake felt his confidence wavering as presentation after presentation showcased abilities that seemed to come from science fiction novels. How could he possibly compete with creatures that could manipulate light, generate plasma, or phase through solid matter? When Professor Zenth called his name, Jake walked to the front of the classroom amid barely suppressed chuckles from his classmates. He could see the anticipation in their faces, expecting to be entertained by Earth's supposedly primitive insects. "Fellow students," Jake began quietly, activating his holographic display, "I want to show you creatures that my homeworld is justly proud of." The first image that appeared was deliberately simple: a common leafcutter ant carrying a piece of green leaf. The reaction was immediate and predictable. Quiet laughter rippled through the classroom as students nudged each other and pointed at the tiny creature. "This is a leafcutter ant," Jake continued, seemingly oblivious to the amusement around him. "Like many of Earth's insects, it might not look impressive at first glance, but I want you to watch what happens next." The display shifted to show a time-lapse view of leafcutter ant colonies at work. Suddenly, the simple leaf-carrying behavior revealed itself as something far more complex. Millions of ants moved in organized streams, but they weren't just collecting food. They were harvesting raw materials for something else entirely. The camera followed the ants underground, revealing vast fungus gardens tended with agricultural precision that rivaled any farming technique in the galaxy. Different castes of ants performed specialized roles. Some cut leaves, others transported them, others prepared compost, and still others tended to growing fungi with careful attention to moisture, temperature, and nutrients. These ants have been practicing sustainable agriculture for 50 million years, Jake explained as the laughter gradually faded. They don't eat the leaves they collect. They use them as compost to grow fungus, which they then harvest as food. They weed their gardens, control pests naturally, and maintain perfect growing conditions. Thelanara leaned forward, her expression shifting from amusement to curiosity. That is actually quite sophisticated. But surely it's just instinctive. Behavior, not real intelligence. Jake nodded as if expecting the comment. That's what we thought too until we tested them. Watch this. The display showed laboratory footage of leafcutter ants being presented with artificial materials they had never encountered before. The ants examined the new substances, tested their suitability for fungus cultivation, and within hours had integrated the best materials into their agricultural system while rejecting unsuitable ones. They can learn, adapt, and make decisions about new situations, Jake continued. But that's just the beginning. Let me show you something else. The scene shifted to honeybees, and Jake could sense his classmates preparing for another round of mockery. Instead, he showed them footage of a hive's decision-making process when choosing a new home. When bees need to relocate their colony, they send out scout teams to evaluate potential sites, Jake explained as the display showed bees flying in different directions. But they don't just report back with locations. They communicate detailed quality assessments. The hologram focused on returning scout bees performing their waggle dances, and Jake began explaining what the movements meant. Distance and direction were encoded in the angle and duration of the dance, but the intensity of the movement communicated the scouts' enthusiasm for the site. It's a democratic voting system, Jake said, watching his classmates' expressions change from amusement to surprise. Scouts debate the merits of different locations through dance, and the entire hive votes on the best option. They consider factors like size, protection from weather, distance from food sources, and exposure to predators. Professor Zenth looked up from his evaluation pad, his multiple eyes focusing intently on the display. You're suggesting these creatures engage in abstract reasoning and collective decision-making? I'm not suggesting it, Jake replied. I'm showing it. The presentation continued with footage of bees making complex decisions about resource allocation, changing their foraging patterns based on seasonal variations, and even using tools to manipulate their environment. What had appeared to be simple flower visiting behavior revealed itself as sophisticated resource management that adapted to changing conditions in real time. Jake's final demonstration focused on monarch butterfly migration, and by now the classroom had fallen completely silent. He showed butterflies that had never made the journey before navigating thousands of miles with precision that exceeded most galactic navigation systems. They use multiple navigation methods simultaneously, Jake explained. Magnetic field detection, polarized light patterns, solar positioning, and genetic memory. They can correct their course for weather patterns, geographic obstacles, and seasonal changes. The display showed satellite tracking of butterfly migration routes, with course corrections and adaptive behaviors that would challenge the Academy's own navigation computers. These delicate creatures were processing environmental data and making navigation decisions that pilots with advanced instruments would find impressive. Krikstal's crystalline form had stopped chiming entirely as he stared at the migration data. The computational requirements for simultaneous multi-system navigation are considerable. How do such small creatures process that much information? That's what we're still trying to understand, Jake admitted. But here's what we do know. Earth's insects have evolved solutions to problems that challenge our most advanced technologies. They've perfected agriculture, navigation, communication, and social organization through millions of years of evolution. The classroom remained silent as Jake's presentation concluded. The creatures that had been mocked just days earlier now appeared in a completely different light. They weren't impressive because of individual abilities like plasma weapons or light manipulation. They were impressive because they had solved fundamental problems of existence through cooperation, adaptation, and collective intelligence. Thelanara was the first to speak, her voice thoughtful rather than dismissive. Professor Zenth raised one of his tentacles to interrupt Jake's presentation, his multiple eyes narrowing with what appeared to be skeptical concern. The murmur of impressed conversation that had been building in the classroom suddenly died away, as all attention focused on the mentoring professor. "Student Morrison," Professor Zenth said in his most academic tone, "while your presentation has been quite entertaining, I must express some concern about the accuracy of your data. The behaviors you describe seem rather exaggerated for such simple creatures." Jake felt his heart sink as several of his classmates nodded in agreement. Thelanara, who had seemed genuinely impressed moments before, now looked uncertain. Crystal's crystalline body had resumed its skeptical chiming. "The footage you've shown could easily be manipulated or taken out of context," Professor Zenth continued. "I find it difficult to believe that creatures lacking sophisticated neural networks could engage in the complex behaviors you've described." Murmurs of agreement spread through the classroom. A student from the methane world of Titan Prime spoke. Our atmospheric analyzers show that Earth's insects have extremely limited brain capacity. How could they possibly perform navigation calculations that challenge our quantum computers?" Jake looked around the room, seeing doubt creeping back into faces that had moments ago shown genuine fascination. The careful work he'd done to change their perceptions was crumbling before his eyes. Thelanara leaned forward, her expression apologetic but firm. "Jake, I want to believe what you've shown us, but it contradicts everything we know about neural complexity and intelligence. Perhaps your researchers have misinterpreted instinctive behaviors as genuine problem-solving." The criticism stung because Jake could understand their skepticism. He was asking his classmates to accept that creatures they'd dismissed as primitive were actually more sophisticated than many technologies they use daily. Without direct evidence, it must seem like wishful thinking. "Professor," Jake said, his voice steadier than he felt, "what if I could provide live demonstrations? Real-time evidence that can't be manipulated or misinterpreted?" Professor Zenth's tentacles swayed, and what Jake had learned was the mentory equivalent of raised eyebrows. "Live demonstrations? Student Morrison, we are quite literally on the opposite side of the galaxy from your homeworld." "But we have quantum communication arrays," Jake replied, pulling out his personal communicator. "I have contacts on Earth who specialize in insect behavior research. They could provide real-time holographic feeds of actual experiments." The classroom buzzed with interest, though Jake could still hear undertones of skepticism. Professor Zenth considered the proposal for several long moments before nodding slowly. "Very well. If you can arrange genuine real-time demonstrations, I will allow them as part of your presentation evaluation." Jake's fingers moved quickly across his communicator, sending priority messages to contacts on Earth that his sister had provided. He explained the situation and his desperate need for live demonstrations that could prove Earth's insects possess the intelligence he claimed. The first response came from Dr. Sarah Martinez at the Colorado Insect Intelligence Laboratory. Her face appeared on Jake's communicator screen, slightly fuzzy due to the vast distance but clearly excited by the challenge. "Jake, I've got a honeybee problem-solving experiment running right now that would be perfect for your demonstration," she said. "Give me 10 minutes to set up the holographic transmitters." While Dr. Martinez prepared her demonstration, Jake received responses from two other researchers. Danny Rodriguez at an Anderson Field Station could show Army ant coordination in real time, and Dr. Helen Wright had monarch butterflies in her migration study facility that could demonstrate their navigation abilities. Professor Zenth activated the classroom's advanced holographic system, creating a three-dimensional display space large enough for detailed observations. The quantum communication array established connection with Earth, and suddenly Jake's distant homeworld felt much closer. Dr. Martinez appeared first, her laboratory materializing around her in perfect holographic detail. The alien students leaned forward with intense curiosity as she gestured toward a complex three-dimensional maze constructed of transparent tubes. "This is a problem our bees have never encountered before," Dr. Martinez explained, her voice carrying clearly across the galactic distance. "They need to navigate from the entrance to a sugar water reward at the center, but the path requires them to make decisions about route efficiency and remember dead ends. She released a single honeybee into the maze entrance, and the classroom watched with fascination as the tiny creature began exploring. At first, the bee's movements seemed random, but patterns quickly emerged. When it encountered dead ends, it backed out and tried different routes. More importantly, it began avoiding paths it had already tested. "Notice how she's mapping the maze in real time," Dr. Martinez continued. "She's not just wandering randomly. She's eliminating unsuccessful routes and building a mental map of the space." Crystal's chiming grew more intense as he watched. "The computational requirements for three-dimensional spatial mapping are considerable. Our crystal beetles require specialized neural clusters for similar tasks." The demonstration became even more impressive when Dr. Martinez introduced a second bee to the same maze. Instead of starting from scratch, the newcomer performed a brief communication dance with the first bee, then proceeded directly toward the correct path with only minor course corrections. She just downloaded the maze solution from her sister. Dr. Martinez explained, "Bees can communicate abstract spatial information through dance, including details about three-dimensional navigation problems." Professor Zenth made rapid notes on his evaluation pad, his skeptical expression gradually giving way to scientific fascination. "The information transfer protocols appear remarkably sophisticated for such a decentralized nervous system." The second demonstration connected to Danny Rodriguez's field station deep in the Amazon rainforest. The holographic display filled with the sight and sound of a living jungle, and Jake could see his classmates react with surprise at the sensory richness of Earth's ecosystems. "I'm tracking an army ant column that's encountering a stream they need to cross," Danny explained, adjusting his cameras to focus on thousands of ants moving through the forest floor. "Watch how they solve this engineering problem." The alien students observed in amazement as army ants began linking their bodies together to form a living bridge across the flowing water. But this wasn't simple instinctive behavior. The ants were actively problem-solving, adjusting their bridge design as water flow and weight distribution changed. "There's no central command here," Danny continued. "Each ant is making individual decisions based on local information, but the collective result is a sophisticated engineering solution that adapts in real time to changing conditions." Thelanara watched with growing excitement as the ant bridge modified itself to handle heavier traffic loads. "This is like our battle wasp formation flying, but without any command hierarchy. How do they coordinate so perfectly?" "That's what we're still studying," Danny admitted. "But somehow millions of individuals can work together to solve complex problems without any central planning or communication system." The third demonstration came from Dr. Helen Wright's butterfly research facility, where monarch butterflies were being tracked during their preparation for migration. The holographic display showed dozens of butterflies in a large enclosed environment designed to test their navigation abilities. "These butterflies have never made the migration journey before," Dr. Wright explained, "but watch what happens when I introduce navigation challenges." She activated devices that altered the magnetic field patterns, changed the polarized light conditions, and even shifted the apparent solar position. The butterflies immediately began adjusting their orientation, compensating for each change, with precision that impressed even Professor Zenth. "They're processing multiple navigation inputs simultaneously," Dr. Wright continued. "Magnetic field detection, polarized light analysis, solar positioning, and internal timing mechanisms. The computational complexity rivals our most advanced guidance systems." Zephyr condensed into his most solid form, clearly excited by what he was observing. "Our phase shift navigation requires quantum processors to handle similar multi-input calculations. These creatures are doing it with organic neural networks." But the most impressive demonstration came when Dr. Wright introduced butterflies that had been artificially displaced from their normal migration route. Instead of continuing on their original heading, the butterflies quickly determined their new position and adjusted their flight paths to compensate. "They're not just following pre-programmed routes," she explained. "They can calculate position corrections and adapt their navigation in real time based on environmental feedback." As the 3 demonstrations concluded, the classroom fell into stunned silence. The live, real-time footage had provided irrefutable evidence that Earth's insects possessed intelligence and problem-solving, abilities that challenged the assumptions of advanced galactic civilizations. Professor Zenth was the first to speak, his voice carrying newfound respect. The silence that followed Jake's live demonstrations stretched for nearly a full minute, broken only by the soft humming of the classroom's environmental systems. Professor Zenth sat motionless at his desk, his multiple eyes still focused on the space where the holographic displays had shown Earth's insects solving problems with elegant intelligence. Finally, the mentoring professor began to speak, his voice carrying a tone that Jake had never heard before in any of his classes. In 40 years of teaching comparative biology across the galaxy, I have rarely encountered evidence that so completely challenges established scientific assumptions. He stood up, his 6 tentacles moving in what Jake recognized as a gesture of deep respect among the mentoring people. Student Morrison, your presentation today has revealed that our galactic databases contain fundamental errors about Earth's arthropod species. The intelligence and problem-solving capabilities we observed represent biological achievements that deserve comprehensive study. Murmurs of agreement rippled through the classroom, but these were very different from the mocking whispers that had greeted Jake's topic selection just days earlier. Now his classmates spoke in tones of scientific excitement and genuine curiosity. Thelanara was the first student to approach Jake's desk as the formal class period ended. The proud Coraxian warrior looked almost embarrassed as she spoke. Jake, I owe you an apology. When I laughed at your insects, I was judging them by the standards of individual combat prowess that my people value. She gestured toward her presentation materials, which still showed images of the impressive battle wasps of Corax. Our warriors are magnificent, but they're specialists. They excel in battle conditions, but struggle to adapt to new environments or challenges. Your ants and bees have something our creatures lack: the ability to innovate and work together to solve problems they've never encountered before. Jake nodded, understanding the difficulty it must have taken for someone from a warrior culture to admit such limitations. Your battle wasps are incredible individual fighters, he replied. But Earth's insects evolved differently. They succeeded through cooperation rather than individual superiority. Crystal approached next, his crystalline body resonating with harmonious frequencies that indicated deep thought. The navigation capabilities your butterflies demonstrated exceed our crystal beetle's light manipulation abilities in computational complexity, he admitted. Our creatures can bend photons and create beautiful displays, but they cannot process multiple information streams simultaneously the way your monarchs do. The Vextari student paused, his transparent form flickering with what Jake had learned indicated uncertainty. I have been considering the implications of what we observed. Our beetles are beautiful and possess impressive abilities, but they are limited to environments where light manipulation provides advantages. Your insects have conquered every environment on your planet through adaptability. Zephyr condensed into his most solid form to join the conversation, his gaseous nature making his excitement palpable in the air around them. The army on coordination we witnessed operates without any central command structure, he said, his voice carrying wonder. Our phase shifters can pass through solid matter, but they lack the collective intelligence to work together on complex engineering projects. More students gathered around Jake's desk, each offering their own perspectives on what they had witnessed. The Delphian student Myrthala noted that while her deep-sea crustaceans could survive crushing oceanic pressures, they couldn't match the agricultural sophistication of leafcutter ants. A student from the crystalline moon of Keth admitted that their energy-shielded arthropods, while impressive defensively, lacked the problem-solving flexibility demonstrated by Earth's honeybees. Professor Zenth observed these conversations with evident satisfaction before calling for attention. What we have witnessed today represents more than just a successful student presentation, he announced. This has been a fundamental lesson in the dangers of scientific prejudice and the importance of thorough investigation. He activated the Classroom's main display, showing comparative data from all the student presentations. Each of your homeworld species excels in specific areas: combat prowess, energy manipulation, environmental adaptation, or specialized abilities. But student Morrison's research has revealed that Earth's insects have achieved something perhaps more valuable: general intelligence and universal adaptability. The display showed migration routes of monarch butterflies overlapping with the territorial ranges of various alien arthropods. The Earth insects' ranges covered far more diverse environments and geographic challenges than any other species presented. True biological success, Professor Zenth continued, may not be measured by the power of individual abilities, but by the capacity to thrive in any environment through cooperation and adaptation. Earth's insects have been perfecting these skills for millions of years, while many of our civilizations were still developing basic technology. Jake felt a surge of pride, not just for himself, but for the tiny creatures that had been dismissed so casually just a week ago. His presentation had accomplished more than defending Earth's insects. It had opened an entire classroom of advanced alien students to new ways of thinking about intelligence and biological achievement. Over the following days, the impact of Jake's presentation spread far beyond Professor Zenth's classroom. Word of the live demonstrations reached other faculty members, and soon Jake found himself invited to present his research to advanced graduate seminars and even faculty meetings. Dr. Yethmara, the Academy's leading expert in collective intelligence, requested copies of all Jake's research data. Your insects demonstrate distributed problem-solving capabilities that could revolutionize our understanding of group dynamics and artificial intelligence, she explained during their meeting. The Academy's Department of Navigation Sciences asked for detailed information about monarch butterfly migration techniques. Professor Quinder, whose species had developed some of the galaxy's most advanced positioning systems, admitted that butterfly navigation methods could improve existing technologies, even the agricultural sciences. Department showed intense interest in leafcutter ant farming techniques. Dr. Zorthak, whose people had been practicing advanced agriculture for millennia, wanted to study ant methods for sustainable crop management and pest control. Jake began receiving messages from research institutions across the galaxy requesting collaboration on studies that would combine alien technology with Earth insect intelligence. Universities on dozens of worlds wanted to establish exchange programs specifically to study Earth's arthropods. The most significant change, however, came in the form of an official announcement from the Galactic Biological Preservation Council. Earth's insects were being fast-tracked for inclusion in the Protected Species Database, with special recognition for their contributions to biological sciences. 3 weeks after his presentation, Jake received a quantum communication message from his sister Lisa back on Earth. Her excitement was evident even across the vast galactic distance. "Jake, you won't believe what's happening here," she said, her image flickering slightly due to transmission interference. "We're receiving research funding requests from universities across the galaxy. Everyone wants to study our insects now. The work we've been doing for years is suddenly considered cutting-edge galactic science." She showed him footage of new research facilities being constructed specifically for insect intelligence studies, funded by grants from alien civilizations that wanted to understand Earth's approach to biological problem-solving. "More importantly," Lisa continued, "we're being invited to participate in galactic research collaborations. Earth is being recognized as a center for biological intelligence research, all because you convinced a classroom of alien students that our insects were worth studying." Jake felt a deep sense of satisfaction as he walked across the Academy campus that evening. His alien classmates now greeted him with genuine respect and curiosity, often asking follow-up questions about Earth's insects, or sharing their own observations about biological intelligence. Thelanara had become particularly interested in comparative studies between Coraxian battle wasps and Earth's army ants, exploring how different evolutionary pressures had produced such different approaches to group coordination. Crystal was working with Jake on a research proposal to study how crystal beetle Light manipulation abilities might be combined with butterfly navigation techniques. Even Professor Zenth had changed his teaching approach, using Earth's insects as examples of alternative evolutionary strategies throughout his curriculum. The creatures that had once been dismissed as primitive were now featured prominently in advanced biology courses as examples. Sophisticated problem-solving and adaptation. As Jake passed the Academy's research gardens, he stopped to watch some Earth insects that had been brought to Zarian Prime for study. A small group of honeybees, working in specially designed observation hives, were adapting their foraging patterns to the alien environment with typical insect efficiency. Nearby, a colony of leafcutter ants had established fungus gardens using local plant materials, demonstrating their agricultural adaptability in real time. Even in this strange environment,